Class, in this video, we're going to be talking about finding angle measures using trig. Now, if you know sine, cosine, and tangent as ratios of an angle, then you can use the inverse of the ratio, sine inverse, cosine inverse, tangent inverse, to find the measure of the angle. Let's talk about inverses for a second, right? So when we talk about inverses, we know that inverses undo the operation in essence. Right? And so when we're thinking of inverses, so if I add, I know that the inverse of addition is subtraction. If I multiply, I know that the inverse of multiplication is division. If I am, raising something to a power, such as x squared, that the inverse is going to be the square root of x, right? So these are all inverses, they're all undoing them. So then when I have something such as sine of x, the inverse of this will be sine inverse of something gives me x, right? So that's kind of what the inverse does, right? It undoes the operation of signage. So that's what we're doing here. We're basically trying to use the inverse, and sometimes inverses are also denoted as arc. So we might have arc sine, arc cosine, or arc tangent are another way to denote sine inverse, cosine inverse, or tangent inverse, but they're understood to be the same. So let's take a look at this first one. So here, let's find the value of x, round to the nearest tenth. So if I'm trying to find the value of x here, I notice that what I have available is the 15 and the 24. So which one of my trig functions would make the most sense to use here? I hope you're thinking sine, because I know that sine of x degrees is going to be equal to 15, which is the opposite over that hypotenuse 24. So because I don't know what x is, right, so now I would be using x equals sine inverse. So essentially what's happening here, and let me take a step back, what is happening here is we're going to apply sine inverse to both sides. Because whatever I do to one side, I have to do to the other side of an equation, right? So when I take the sine inverse of sine, well, that just undoes itself. So I'm left with the input of x. So here this is equal to sine inverse of 15 over 24. Okay. So now what is sine inverse of 15 over 24? Well, we're going to make sure that your calculator's in degree modes. We'll get x is equal to 38.7 degrees. Okay. All right, let's try another one. Let's look at number 3 here. So for number 3, right, notice that this is the right angle, so this tells me that this is the hypotenuse. So I'm really left with the adjacent and the opposite. So this is telling me which trig function would be the best fit here. I hope you're thinking tangent. So tangent of x is going to be equal to 20 over 37. Okay, so now again, I'm going to apply tangent inverse to both sides of the function. And notice that tangent inverse of tangent, that undoes the function, so I get x. And so I'm left with tangent inverse of 20 over 37, which gives me, again, making sure your calculator's in degree modes, we're going to get 28.4 degrees. Okay. Now, since when we're looking at these calculations, if you don't have a calculator, you can use the Desmos Scientific Calculator. That's totally fine. And let me show you where you can find those functions. So once we're at the Desmos Scientific Calculator here, notice I have sine, cosine, and tangent here. But if I click on functions, now I have inverse sine, inverse cosine, and inverse tangent. So let's look at that last one again. So I would take inverse of tangent. I'm going to come back over here to the main menu. And then here I would go ahead and do 20. And then I would divide that by 37 was the number. And so now when I hit enter, notice that I get 28.39. We're just going to round that to the nearest tenth. And so we'll get 28.4 degrees. Okay. So no worries if you don't have a calculator. I don't know how good the cell phone calculators are, but you can always use Desmos or GeoGebra. Both of those would work fine. All right, so let's take a moment and let's have you try some of these. Go ahead and try 5 through 6 and see if you got it. All right, so hopefully you were able to kind of follow along here. So for number 5 here, we have sine of x is the best trig ratio to use just because we're looking at opposite over hypotenuse. So we're going to take the inverse sine of both sides and we get x is equal to 77.3 degrees. Over here for number 2, we have cosine of x is equal to 8/11, right? And it is cosine is the best because we have the hypotenuse here and we have the adjacent side here. So looking at those two, that would be the best trig ratio. We take the inverse of both sides, cosine inverse of both sides, and we end up with x equals 43.3. And for number 4, I hope you also got using cosine x, and then the missing angle was 38.5. And lastly, number 6, we used tangent of x because we were missing the hypotenuse, and we took tan inverse of both sides, and we got that x is equal to 54.5 degrees. All right. So hopefully you're following along just great there. Let's look at some review here. Find the value of x and round around to the nearest tenth, right? And so again, we're looking at, this is review from one of our last videos. So here, because I have this side that I'm looking for, I have this degree, and I know that I have the opposite and the adjacent side. This tells me that the best ratio is going to be tangent. So tangent of 39 degrees is going to be equivalent to 11 over x. So now I'm going to multiply both sides by x, so I end up with x times tangent of 39 degrees is equal to 11. I'm going to divide both sides now by tangent, so I get x is equal to 11 divided by tangent of 39 degrees. Okay, let's go ahead and plug that into our calculator. And again, we could use Desmos for this, so let's just show that. So we're going to come over here to Desmos, and we're going to go ahead and do 11 divided by, and then we're going to click on tangent of, making sure, notice here, this is where we will toggle between degrees and radians. We're going to use degrees, 39 degrees, and let's go ahead and close that off and hit enter. So we get 13.58, which when we round to the nearest tenth, that gives us x equals 13.6 degrees. Sorry, not degrees, this is a side. All right. So again, this is review. So go ahead and try 9, 8, and 10 just to make sure we still got it. All right. So in reviewing that, hopefully you got, let's take a look here for number 8. So we're using cosine. Notice that we have the x value here. The hypotenuse is available. So we know that we're looking for our adjacent over our hypotenuse. So that's going to be cosine. And so we should get that length is 19.5. For number 9, we have tangent. Again, we're missing that hypotenuse here, so we have the adjacent and the opposite, and so that's going to transition into that tangent trig ratio. And so we end up with a result of x equals 6.5. Number 10, we have sine of 24 degrees. That's going to be x over 31, and so we multiply both sides by 31, we get x, and so we end up with 12.6 is the missing side. All right. Let's continue here. So looking at number 11 through 14, now we're practicing using the inverse trigs functions, right? Because now notice that the angles are what's missing. So when the angles are missing, we are going to be looking at those inverse trig functions. So looking at here, I have a hypotenuse available and I have an adjacent side available. This tells me that the best trig ratio is going to be cosine. And so I'm going to have cosine of x is going to equal 14 over 22. So with this, we're going to go ahead and take the inverse of cosine inverse of 14 over 22, and then this tells us that x is equal to cosine inverse of 14 over 22. So we're left with x equals, well, let's go ahead and plug that in. So again, we're going to hit functions. We're going to come over here to cosine inverse. And now we're going to go ahead and plug in 14. Come back over here to the main menu. 14 divided by 22. And just hit enter. So we get 50 point, rounding to that nearest a tenth place, 50.5. Okay, and that's going to be degrees. So we want to make sure we're in that degrees mode. All right, for number 12, let's take a look at this. So we have the opposite and the adjacent, right? So we don't have the hypotenuse. This is going to tell us that we're going to use tan of x, and this is going to equal 25 over 78. So we're going to take tan inverse of both sides. Oops, I changed that number by accident. There should be a 5. All right, and so then this tells us that x is equal to tan inverse of 25 over 28. Let's plug that into our Desmos calculator over here. So we're going to have functions. We're going to get tan inverse, come back over here to the main. We're going to do 25, and let's divide that by that 78. And so we're left with 17.77, rounded to the nearest tenth. That's going to give us that 17.8 degrees. Okay. All right, go ahead and try 13 and 14. All right, so looking at number 13 here, cosine of x is the best trig function for us to use for this problem. So we have 31 over 36, and then we find out that that degree is going to be 30.6. Okay. For number 14, we have sine of x, right? 10 over 19, right? Because notice that this is our hypotenuse there. So that's the best trig ratio to use. We're going to go ahead and take the inverse on both sides, and we end up with x equals 31.8 degrees. All right, let's go ahead and looking at some more complex shapes here and finding what is being asked of us. So we here for number 15, we are looking for, we want to find DE. So DE is the line segment that goes from D to E here. Okay, so this is the side that we want to find, right? And so we can go ahead and label this. Let's go ahead and label this X. How do we go about finding this side? So notice we do have two triangles here. This triangle on the bottom that contains DE only gives us the angle 19 degrees. Okay, I don't have any other side lengths. So I need to figure out, okay, what's happening with this upper triangle here. So I am going to need at least something else. So for instance, one thing that I could acquire is this length here. So let's call this Y. Okay. So if I acquire that length there, then at least I have another side and I have an angle, and then I can use one of my trig identities to find this. All right, so let's look at this top triangle then. I have a side here, I have an angle, and I have a side. So we want to find y first. So we're going to start off by finding y. So to find the y value of y, I'm going to use this angle here that I'm given, which is the 61 degrees. And so notice, because I don't know the hypotenuse, but I do know the, I'm looking for the opposite side, and I have the adjacent side. This tells me that the best trig function to use is going to be tangent. So I'm going to take tangent of 61 degrees is going to be equal to my y value over 24. So I'm going to go ahead and multiply 24 to both sides, so I get tangent of 61 degrees equals y. Let's go ahead and plug that into our calculator. So we're going to get 24 times, we're going to come over here to tangent of 61. And we hit enter, so we get 43.3 as our value. We're going to come back over here. So we know that y equals 43.3. So that tells me this side here. So now I'm trying to find the other side. So I have an angle, and I don't know the hypotenuse, but I have the two sides, the two legs. So this tells me that in order for me to find x, which is the true question, we're going to take tangent again. So we're going to take tangent of 19 degrees, and that's going to be equal to our x value over our y value, which was at 43.3. Okay. All right, so let's go ahead and multiply both sides by 43.3. This equals x. So therefore, x is going to equal, let's come back over here to our calculator. We're going to get 43.3 times that by our function tangent of, what was that, 19 degrees. Let's go ahead and close that off, and we hit enter. I get 14.90, so it's going to be 14.9. Okay, and so that is our x value, which is really what we were looking for. Okay. All right. Go ahead and look at number 16 and go ahead and find the answer to number 16. So if you look at number 16, it's really asking you for this notation here. It comes from geometry. This is telling you the angle measurement of W. So you're really looking for this spot right here. So if we call this theta, what is theta? That's what you're looking for. So see if you can figure this one out, and then we'll come back and review it. All right, so to find the angle measurement of W, which is really what I denoted right before the pause here, was theta, that's our goal. So notice that I drew this red line here because in order to find theta, I need more information on this triangle. So that A symbolizes another length that I could use. So essentially, once I know what A is, I can use tangent of theta is equal to A over 22. So let's figure out what that A is. So I come back to the second triangle that's on this end here, and I say, all right, well, if I know what 25 degrees is here, and I have 15, and I really need to know A, that tells me that I need to use sine. So I'm going to take sine of 25 degrees over 15 over A. And then, so then this becomes A equals 15 over 25, sine of 25 degrees. So we get that A is 35.5. So now we're going to go ahead and plug that in to our tangent here. And we can now use arc tangent, or, we could say tangent inverse to undo the tangent function. And we get theta is equal to 58.2 degrees. Hopefully you were able to follow that along. All right, let's look at these application problems right before we end here. So I'm going to have you try number 17 on your own. So take a moment and try it out. Great. So once you took that pause to try it out, I hope you found that with that ladder leaning up against that wall, we're at a 75-degree angle right there. And so from the ladder to the wall, we had 6 feet of a difference. So looking at that, we know that if we're trying to find x as the length of the ladder, how long that ladder is, we're going to use cosine of 75 degrees, which equals 6 over x, and we're left with x equals that 23.2 feet. And again, just a simple sentence, the ladder is 23.2 feet. All right, let's look at number 18 here, and this will kind of be the end of the notes for this section. So for number 18, it says, Jaden is flying a kite and lets 275 feet of string. If the kite is 150 feet above the ground, and assuming the string is straight, what angle does the string make with the ground? Okay, so let's take a moment to kind of think about this, right? So he's flying a kite. I always like to draw pictures. They make everything make more sense. He's flying a kite, so here's our kite, right? And lets off 175 feet of string, right? So here's our string. So 275. If the kite is 150 off the ground, so here's 150 feet off the ground, assume the string is straight. What angle does the string make with the ground? So if this is our ground here, we're looking for this angle here. This is our theta that we're looking for. Okay. So noticing here, because I have the opposite over the hypotenuse, then in this case, I would want to use sine. So I'd have sine of theta is equal to 150 divided by that 275. Now, because I don't know what theta is, we're going to go ahead and take the inverse sine of both sides. And then we're going to go ahead and once we take the inverse sine of both sides, I'm left with theta on this side, and I have to look for the inverse, sine inverse of 150 over 275. So our sine inverse then, let's go ahead and put that into Desmos. So we're going to have sine inverse of 150 divided by that 275. And so here we see that we get 33.05. We're rounding this to the 10th place. So that gives us that our theta is going to be equal to 33.1 degree. Okay. And so lastly, we'd say the angle the string makes is 33.1 degree. Okay. All right, and that's it for this section.